Hello everyone, today I will talk about how to construct a height balanced binary search tree from a list. What is a height balanced binary search tree? It's a binary tree where the depth difference between the left and the right subtrees is not more than 1. Here are two binary search trees. The left tree is not a height balanced tree because its left subtree has 3 levels. 1, 2, 3, and the right subtree only has 1 level. The depth difference is more than 1. However, the right tree is a height balanced tree. If you look at this balanced tree carefully, you can find the middle number of the list is the root of this binary tree, and the elements on the left side of the middle number form the left subtree. The elements on the right side of the middle number represent the right subtree. So by repeating this approach recursively on the left and right side of the middle number in the list, we can form the balanced binary search tree. Let's see this example. 6 is the middle number of the whole list, so we let 6 be the root. The middle number on the left side of 6 is 3, so we let 3 be the left node. And the middle number on the right side of the 6 is 12, so let 12 be the right node. Then we found that 1 is the left node, 5 is the right node, and 10 is the left node. So we are done with the binary construction. The key idea here is to link the middle numbers to the root, left subtree, and the right subtree. Okay, let's see the code. In the list to the binary tree conversion function, first we check whether the list is empty or not. If it is empty, return none. Otherwise, we found the middle number of the list and then assign the middle number of the list to the node. Finally, we recursively construct the left and right subtree from the list. In the binary to list function, we use while loop to output the node value on the current level. If the node on the current level is not empty, we output the value and the right and left subtree. Otherwise, we output none and break the loop. Okay, that's all for today. See you next episode.